The question is show that root 7 plus root 3i by root 7 minus root 3i plus root 7 minus root 3i by root 7 plus root 3i is real. So we will take the number root 7 plus root 3i divided by root 7 minus root 3i plus root 7 minus root 3i divided by root 7 plus root 3i. This can be done in two ways. Either multiply the numerator and denominator of the first term with the conjugate of the denominator. Same way do it with the second term and simplify. Otherwise here what I am going to do here is I am just going to cross multiply, means like the same way as we take the LCM. Okay. So the denominator will be root 7 minus root 3i into root 7 plus root 3i. And the numerator is root 7 plus root 3i into root 7 plus root 3i, which gives you root 7 plus root 3i the whole square. This term into the same term gives you the term square. Same way plus here also root 7 minus root 3i into root 7 minus root 3i again gives you root 7 minus root 3i the whole square. This is of the form z1 plus z2 the whole square. So expanding what I get z1 square, that is root 7 square, which is 1, plus z2 square. z2 square is root 3i the whole square. Root 3 square is 3 and I square is I square. Plus 2 into root 7 into root 3i. So plus 2 into root 7 into root 3i. Plus here also a square or z1 square gives you 7 plus root 3i the whole square gives you 3i square minus 2 into root 7 into root 3i whole divided by denominators of the form z1 minus z2 into z1 plus z2, that is a minus b into a plus b form. So we are getting a square, that is root 7 square minus root 3i the whole square, that is equal to 2 root 7 root 3i and minus 2 root 7 root 3i gets cancelled. 7 plus 7 gives you 14. What is this I square? Negative 1, isn't it? So negative 1 into 3 gives you minus 3. We took 7 and 7 and we wrote 14. We took 3i square, we wrote negative 3, and one more term is there in the numerator, that is also I square into 3. I square is negative 1 into 3 gives you minus 3 divided by denominator root 7 square is 7 minus root 3i the whole square is again 3i square, which is equal to 14 minus 6 divided by 7. I square is negative 1. Negative 1 into negative 3 gives you plus 3. That is 8. 14 minus 6 gives you 8 by 7 plus 3 gives you 10. Isn't it? If I need to simplify, I can write as 4 into 2, 8, and 5 by 2, 10. 4 by 5. What was the question to show that it is real? It is real. Why? Because its imaginary part is absent. If I want to write it as in the form a plus ib, I can write as 4 by 5 plus 0i. And we already told that if a plus ib, in a plus ib be equal to 0, a is purely real, isn't it? Same way, here also we are getting 4 by 5, which is purely real. That was what we have to prove.